Good afternoon, students. Let's start our lessons. Okay. See, we were at the matrix, and then we want to find the inverse of the matrix. I already told you there are different methods. One of the methods we are going to do is to find. We are using the cofactor matrix. That is, adjoint of a matrix divided by the determinant of the matrix will give us the inverse. That method. First, I can show you how to find it. Okay. First, what should we find? I already told you that we have to find the minor of each and every members of the matrix, and then we should find the cofactor matrix, and then the cofactor matrix we should take the transpose of the cofactor matrix, then that transpose is divided by the determinant. Determinant means the value of the matrix will give the inverse. Okay, now we see this is the matrix for which we have to find the inverse. Yes, the first member is 4. I already told you that how to find it, isn't it? The minor of this member 4. So, if we want to find the minor of this 4, the row and column in which this 4 is a member should be avoided. Its minor is this one, 0, 1, negative 2, 4. Okay, what is its value? You know it. What is its value? The minor is this 0 times 4 minus 2 times negative 2 times 1. So this value is 0 minus 2 is equal to positive 2. So, we are now going to find a matrix with the minors of each and every member. And so we have to write in the proper place. In the place of 4, its minor 2 should be there. We are going to make another matrix. Okay. So this is the minor matrix. Minor matrix. How does it come? We can see in the first place. In the place of 4, that is the first place, I am going to put 2 here. This is the minor matrix. And then now similarly we have to find each and every member's minors. For this one, the minor will be for this one. It is 2. This one and this one are excluded. The remaining is 2, 4. 2 times 4 here. And then the 2, 1, 3, 4. And then this value is, what is that? 2 times 4, it is 8 minus 3 times 1, it is 3 times 1 is 3 is equal to 5. So I am going to write 5 in the place of this 1 is 5 here. And then minor for this negative 1. What is the minor for this negative 1? You can see this one and this one are gone. Its minor is 2, 0, 3, negative 2. So this determinant value is 2 times 2, it is negative 4 minus 0. It's negative 4 itself. So I am going to put it 4 here. Negative 4 in the place of this negative 1. Now, for the minor for these 2, it is minor for these 2 is this one and this one is 1. But then what is the value remaining? 1, negative 1, negative 2, 4. See 2 and this column is gone, this row is gone. Then 1, negative 1 and negative 2, 4 is the remaining value. So it is 4 minus negative 2 times negative 1, it is 2 itself. So 4 minus 2, it is 2 itself. So we can write 2 in the place of this 2. So minor, it is 2. Similarly, for the minor for this 0, this member is, see this one is gone, this one is gone. Then 4, negative 1 and then 3, this is 3, 4 is there. Then 4 times 4, it is 16, 16 minus 3. So 16 plus 3, it is 90. So we can write 90 here. And then the next one, it is 1. For 1, the value is, determinant minor value is, this one and this one is gone, 2, 0, 3, negative 2. So it is negative 4 minus 0 is equal to negative 4. So I am going to write negative 4 here. And then the next one, it is for 3. For these 3, we can exclude this one and this one. So remaining is 1, negative 1, 0, 1. So it is 1 minus minus 1, isn't it? 0, 1 minus 4 is 0. It says 1 is up. So, I'm going to write 1 here. And for this 2, negative 2, what is coming? You can see it's here, this one and this one is gone. 4, negative 1. See, this one is gone. This one is gone. So, 4, negative 1 and 2, 1. So, this value is 4 minus 2. It is 4 plus 2 is equal to 6. And then comes the last number is 4. The minor value is, see, this one is gone, this one is gone. Here it is gone and it is gone. 4, 1, 2, 0. Okay, so it is 0 minus 2 is equal to minus 2. This minor matrix, we got the minor matrix. To find the cofactor matrix, we have to add the sign also. I know I already told you, it's the, or otherwise, to find the sign, cofactor matrix, Cij. It is I is the row matrix and J represents the column. And this one, see, for the first one, it is C11. It's equal to C11. So to find the sign, it is negative 1 raised to I plus J. Is equal to negative 1 to the power of 2. So we know that it is positive 1, isn't it? This is the way in which we are going to find the signs, the cofactor matrix. Otherwise, I know, I've already told you, you can just think in that way. Instead of getting like this, instead of doing like this, we can find the signs. The first one will be positive, next is negative, next it will be positive, alternative positive and negative will come. And then for the next row, it should be negative, positive, negative, positive, negative. See, it is coming like that. As it is negative, it will be positive, negative, positive. Either column wise or row wise, when we look, we will get, alternative, positive and negatives. See, here, if, for example, the cofactor matrix, to find this one, the minor is there, to find the sign. I can tell you, this is the first row and the second column. And then for that one, C12, we can see it's negative 1 to the power of 1 plus 2 is equal to negative 1 to the power of 3. It is negative 1. See, without calculating that, we already put that it is negative 1. You understand? I think so. This is how we are going to find the signs. Now, this is the minor matrix. Okay? The cofactor matrix is the minor matrix with the proper sign. So, we can add the signs to this one. It's not. So, this is minor matrix, then cofactor matrix. See, the same one. The first one is positive. We are adding positive. This is 2 positive. And then the second is negative. So, negative 5. And the third is, third is positive. So, positive into this one is negative 4 itself. Did you understand? We have, multiplied, the minor matrix with their corresponding signs. So, this is already negative 4. When we multiply this negative 4 by positive, one negative and one positive will make negative. That is how it is remaining as negative itself. And then negative. This 2 is negative 2. And then putting this one, 19 itself, which is positive, negative, with this negative will make a positive 4. And then positive, this one is positive, negative, with this 6, negative 6. And positive, with this negative 2, negative 2 itself. And what do we get? We got the cofactor matrix. Then, inverse of the matrix is adjoint matrix divided by the determinant. Now, we are going to find the adjoint of the matrix. Okay? Okay, so I am going to rub this. Then, adjoint of the matrix. Now, adjoint of the matrix. adjoint matrix is equal to adjoint of the given matrix is equal to transpose of the cofactor matrix. Okay, now transpose, that means the cofactor matrix, I am going to write the cofactor matrix 2, negative 5, negative 4, negative 2, 19, 4, 1, negative 6, negative 2. And then we want to get the transpose. It is the transpose of the cofactor matrix 2. So this is the adjoint matrix. This sign represents the adjoint. How do we get the adjoint matrix? Now this one is not necessary, I am going to rub it. To get the transpose, we have to interchange the rows and columns. Okay, then the adjoint matrix, what is going to get is okay, adjoint matrix, and I am going to take the transpose 2, negative 5, negative 4. This is the row here. I am going to interchange this one as the column. So it is adjoint matrix is equal to 2, negative 5 and negative 4. Similarly, this one, the second row can be changed as the second column. So negative 2, 19 and 4 is the second column. And then comes 1, negative 6, negative 2. 1, negative 6, negative 2. This, now we got the adjoint matrix. Inverse of the matrix is the adjoint matrix divided by the determinant of the matrix. I think I have told you how to find I already told you how to find the determinant of the matrix, isn't it? So we have to find the determinant of the former matrix. Then it is the inverse. So A inverse, the matrix inverse is equal to this one. 2, negative 2, 1, negative 5, 19, negative 6, negative 4, 4, this one divided by the determinant A. This means the determinant A. Now we got the inverse of A, inverse of the matrix. And we have already learned it, isn't it? Okay. Now this is the way in which we can find the inverse of the matrix. Okay. So to find the inverse of the matrix, we should find the adjoint. To find the adjoint, what we should do? We should do the cofactor matrix. To find the cofactor matrix, first we should find the minor of each and every term, every member, and then we should include the respective signs also. Then we will get cofactor matrix. To get the adjoint matrix, we have to take the transpose. Okay, that is what we have done. Okay, now I know we can just go to find the determinant also. And now we know that the inverse of the matrix is adjoint divided by the determinant. So this is the matrix for which inverse is to be found out. So how can we find the determinant? Once more, I am going to explain it. The first member 4 is to be taken and its minor value is to be taken. So for the sign for this, the first member is positive. So 4 into excluding these two, it is 0 times 4 minus 2, it becomes 2. Then the next one is 1, it is minus 1 into, then it becomes minus 1 into 8 minus 3. Then the next one is minus, the first minus, first positive, negative, then positive. That is why this plus sign here with the negative 1 into, its minor is negative 4 minus 0. So we are going to calculate it. See, 4 into 0 plus 2, it is 2 itself, negative 1 into, then 5 minus this plus with this minus becomes a minus. So 1 into negative 4, that is the one we are going to get. So it is 8 minus 5 plus this negative with this negative makes a positive. So the final answer is 7. So what will be the inverse? A inverse is 1 by 7. Already this matrix divided by 7 itself. 1 by 7 into the adjoint matrix. Adjoint matrix we already wrote it. It is 2, negative 1, 1, negative 5, 19, negative 6 and negative 4, 4, negative 2. This is the inverse. This is one method. You should try it. You take another matrix and then you should try it. And then another method we are going to find is using the augmented matrix. What is augmented matrix? Now, this matrix should be taken. If augmented matrix means we are putting some dots here, and then the unit matrix for this one should be taken on the right side. And then what is our purpose is, what is our aim is to change this one, the matrix on the left side as an identity matrix. And then what all we can use the row operations so that the value should not change. Then the augmented matrix on the right side, that is the unit matrix, should be changed into a matrix, and then on the left side it should be a unit matrix. So we can manipulate the rows to get an identity matrix or unit matrix on the left side. Then what we are going to get on the right side is the inverse. Okay, that method we can now well. Okay, this is the matrix, and then now I am going to write the augmented matrix for one. Just look. First we can write 1, 2, 1, 0, negative 1, 2, 2, 3, 1. And then we know how to write the identity matrix for this one. This is a 3 by 3 matrix, so it becomes, first we know the first one member should be 1, and then the second one it is 0, and the third one in this column is also 0, 0, 1, 0, 0, 0, 1. This is the identity matrix for the matrix A. So we are going to call it together with the identity matrix. We call it an augmented matrix. Now what is our purpose is to by row operations. Row operations I know you didn't learn it, but just listen here. Okay. We have to change this one as an identity matrix, so that only on through this diagonal some members are there. It should not be, this is negative 1, already it is 1, 1 here, so we should change this one also. And below the diagonal it should be 0, the members below the diagonal should be 0, and above the diagonal should also be 0. Only some members rather than 0 is along the diagonal only. We have to make it. Okay. Okay, now we are going to do the row operation. R3 is equal to, what I am going to do is R3 is equal to R3 minus 2R1. What does it mean? R3, in the R3 is the third row. In the place of the R3, we are going to replace it by some other members, that is row operations. See, R3, from R3 I am going to subtract it to R1. Why we are doing that? See, our aim is to make 0 in below the diagonals and above the diagonals also. Okay, to make it 0 here. If this one is multiplied by 2, and then if it is subtracted, when it is this one is multiplied by 2, it will be 2, and that 2 can be subtracted from this 2, it will be 0. So to get 0 here, what should we do? Our aim is to make a 0 here, so we know that is 1. This, if we want to multiply this 1 by 2, we should do it along all the members of this R1. So, that is why I wrote R3 is given as R3 minus 2R1. First, that operation can be done, and then what changes will be coming for our matrix we can see. So, the matrix is now changed to be R3 in the place of R3. All other things are remaining as such. 1, 2, 1. I am writing this 1, 2, 1 as such, and also 0, negative 1, 2 as such. only in the place of R3 some changes are coming. So multiplying this one, 2R1. So this 1 times 2 becomes 2, 2 minus 2 it becomes 0 here. And then if you multiply here by 2, we should do it the same thing to the next member also. So 2 times R1, this is 4. So we have to subtract this one from R3. So 3 minus 4, it becomes negative 1. And here, what is coming here? R3. Here R3 is 1 itself. 2 times R1 is 2. Then 1 minus 2. What will be the value? It is negative 1. Again negative 1. See, this is the diagonal and we got 0 here and 0 here. Now our aim is to make a 0 here also. And also here, here and here. Is the 0 should come. Isn't it? This is what we have done on only for this matrix. Now, for you to understand, I am just giving you an idea. R3 is equal to R3 minus 2R1. This is only for this matrix, what I have done. Okay, now we have to take the augmented matrix. Augmented matrix should be considered as a single matrix, and what all operations we are doing here should be done to the other side also. Okay. And the right side, what is coming for the right side? Here we can do it together. This is for the matrix. It's only for the given matrix, this one. For the augmented matrix is now going to be changed as, I'm going to write 1, 2, 1 here, 0, negative 1, 2 here, and 0, this one. How do we get? Okay, this one. 1. Here we didn't do anything, so I can write 1, 0, 0 as such. 1, 0, 0. No change for that. For the second row also we didn't do anything. So I am going to write 0, 1, 0 as such. 0, 1, 0. Only changes are coming for the R3, 2, 3, 1. See, this 2, 3. 2 is changed to be, we have done it. This is 0, this is negative 1, this is negative 1. So the same process should be done to the other side also. What we are going to do? 2 into, here the corresponding member for this 0 is 1. So 0 minus 0 is R3, R3 minus 2 R1. So it is 0 minus 2 into 1. So it is, what will be the value? Negative 2. I think you understood it. It's okay. So here it is 0, here it is 0. Nothing will happen. So we can just write 0 here. And then this one. 1 minus 2 into 0, 2 R1. That is 1 itself. See, the what changes are coming to the corresponding augmented matrix. So when this is I wrote it here. This one is just for you to understand what operations we are doing here should be done to the augmented, the identity matrix also. That is for the full augmented matrix. So we got this much. Now see this one. Here we have to make 0. This is the diagonal, and then again our aim is to make 0 here. Now look at the rows. This one, this negative 1 here, again negative 1 here. To make 0 here, if we subtract this one from this one, that is R2 should be subtracted from R3, we will get 0 here. So that operation we are going to take. So in this case, R3 is equal to R3 minus R2. Then what value we are going to get? Yeah, only the changes are coming. We are making the changes only for the R3, the row R3. So the other ones we can write as such. So it is 1, 2, 1, and then the next one, the identity matrix 1, 0, 0. We wrote it there. The second one 0, negative 1, 2. 0, 1, 0. Then now the third row is here. See this one. If we write 0 here, see we are subtracting R3 minus R2. So 0 minus 0, it is 0 itself. Then negative 1 minus negative 1, it is 0 itself. See, we got 0 here. And the next one, negative 1 minus 2, that is negative 3. Negative 1 minus 2, it is negative 3. Now we can come to the other side, the third row, negative 2, see R3, this is negative 2 minus 0. So we can write a negative 2 here, 0 minus 1, negative 1, and then 1 minus 0, 1. See, now this part, again we want to make these ones. Again, these three, we can make these three as negative 1. We want, no, positive 1. We want to get an identity matrix. And this negative 1 should also be changed to be positive 1. What operations we can do? Okay, now we want to make 0 here. Okay, see this one. It's a lower triangular. After this diagonal, it's a triangle 0 here. If we draw like this, it's a triangle of 0. So we call this one. If it is in this form, we call this one row echelon form. Now we want to change it. These two are 0, isn't it? And now we can. Our aim is like that. What should we do to get a 0 here? We can do some operations to make it 0. It's a R1. We want to make some changes for the R1. R1 is, how can we change this one? R1 is equal to, if it multiply this negative 1 by 2 and then if we add it to these two, it will become 0, isn't it? So R1 is equal to R1, the row R1 is changed to be R1 plus 2R2. Then what all changes are coming, we can see. Then it's a, see, its only changes are coming for the first row R1, that is why we are writing R1, it tends to be R1 plus 2R2. So this matrix is changed to be 1 is R1 is equal to, see, R1 plus these two R2. This is 0 here, so it is 1, it will remain as 1 here. And then negative 1 times 2, it is added to here, it becomes 0. And then, and again see R1. R1 plus 2R2. 2R2, it is 4. Isn't it? 2 into R2. 2 into R2, 4. 4 plus 1, it becomes 5. And now we can do the same thing on the other side also. It's a 2 into 0. When it is added, it becomes 1. It's a, and then this one, it's a 2 into R2C, 2R2 plus R1. So 2 plus 0, it is 2 itself, and then this one is 0 itself. And only the changes are coming for the first row, so we can keep the other rows as such. 0, negative 1, 2, 0, 0, negative 3. See, we got a 1, 0 over this diagonal member. Okay, so the augmented matrix, so that the other side, the right side, it becomes 0, 1, 0, negative 2, negative 1, 1. See, the identity matrix is now changing. Now what is our next aim? Okay, see this one. We are going to multiply this row by this 5 and then the first row by 3 and we are interchanging. Okay, interchanging with these two members because we want to make 0 here. So if we multiply all the members by these 3 and then these 3 by all these members and then 5 by all these members, then we add it to the row 1, we are going to get what, we will get a 0 here. That is our aim. So R1 is now changing to be 3 into this one. We can take negative 3, whatever it may be, negative 3 R1 plus this one. This 5 is to be taken plus 5 R3. Then what all changes are coming, we can see. Do these two operations, 3 R1 plus 5 R3 and write it in the place of R1. and in the place of R2 again we want to change it. These two are 0, so we are going to write 3R2 plus 2R3. 2R3, 2 into R3. Then we are going to get a 0 here, and then the corresponding changes for the right side also. Then what we are going to get, we will get an identity matrix. This negative should also be somehow it should be changed. Okay, then what we are going to get on the right side is the inverse. Okay, one real time the use of inverse I can show you. First you finish this. Okay, see you.